This video will focus on three brilliant researchers: Shoemaker, his astronomer wife Carolyn, and Australia's own Andrew Glikson. I describe a new catastrophist theory of geological history and present it against the background of turbulent technological change that continues today. My last practicum at Cleveland Street High School, Redfern, in 1968 convinced me to dedicate my life to classroom teaching. I took my Year 11 physics class to the historic Sydney Observatory. "Look at this, sir," they said, and I gazed in awe at the globular star cluster Omega Centauri near the Southern Cross. It can be seen in binoculars as a fuzzy ball. My closest childhood friend was Jewish-Hungarian refugee Nick Lom. 6 in the state in physics, he did a PhD on quasars and dedicated his life to promoting astronomy as curator of the Sydney Observatory. He claimed that Sydney was wasting too much energy by beaming it upwards. This meant that the 5 stars of the Southern Cross are reduced to 3, and we never see our galaxy over the Sydney sky. I have seen the Milky Way on a geology trip with my students to Peenemunde, north of Broken Hill. Its sight blew me away. Nick has promoted Earth Hour and encouraged use of lights that reflect downwards and use energy-efficient LED lights. The recognised father of geology was William Smith. His published work included a map of Great Britain, a stratigraphic column of rock layers, and the fossils that they contained. Darwinian evolutionary theories which followed suggested that life changes gradually with time. Born in France of Swiss ancestry, Georges Cuvier accepted stratigraphic columns but opposed evolution theory. Studying a range of extinct fossils from all over the world, he formed the view that they were killed off by a series of catastrophic events. Here are some of his fossil examples. Late in World War II, German SS Major Werner von Braun finally finished his V2 rocket and began production using slave labourers in underground tunnels at a place called Peenemunde. An estimated 20,000 prisoners died. The V2s were the forerunners of modern Scud missiles, tracked and destroyed by our SAS today. This is what they can do. My uncle, serving with a RAF in Britain, miraculously survived the bang. Others near him were cut to pieces. Von Braun and his team surrendered to the Americans and built the rockets that took them to the moon. The Soviets developed their own Katyusha rockets in World War II. They captured some scientists and V2 rockets and eventually built huge R7 rockets to launch satellites and people into orbit. Their present spaceport is the Baikonur Cosmodrome in Kazakhstan. On the 4th of October 1957, the Russians successfully launched the world's first satellite. Sputnik 1 was a 2-foot diameter polished metal sphere, broadcasting beeps for 3 weeks before the batteries ran out. Sputnik 2 carried a poor little dog called Laika. On 12th of April 1961, after a number of rocket failures, the Russians dared to send a man into space. Yuri Gargarin was 5 foot 2 inches tall and just able to fit into a Vostok capsule. It was a wild 2-hour ride. Finally, he was ejected from the capsule and parachuted 7 kilometres to the ground. He did not enjoy fame. His successor died during liftoff, and Yuri was killed in a plane crash in 1969. The Americans were not far behind. In May 1961, Alan Shepard reached space in a Gemini capsule. He eventually walked on the moon. February 1962 saw astronaut John Glenn orbit the Earth 3 times manually, piloting a dysfunctioning capsule. In October 1962, the Americans and Russians were building nuclear-tipped rockets. American Jupiter missiles were stationed close to Russia in Turkey. Premier Khrushchev began to move some of his missiles to Cuba. There followed a 13-day standoff as Kennedy tried to stop the ships and threaten war. Australian pilots sat in their cockpits, and my dad was one of many officers who sat in full uniform, bags packed, by the phone before there was an agreement. Withdrawal from Turkey and no missiles in Cuba. There followed a frantic arms build-up and weapons testing. Radioisotopes in the polar ice cap layers could foretell the human race's final destruction. Now there is a new arms race as more countries build weapons of mass destruction. In May 1961, President Kennedy announced that America would launch the Apollo program with the aim of putting a man on the moon. Gene Shoemaker was hired by the United States Geological Survey in 1950 to find minerals. His work led him near the Barringer crater in Arizona that was thought to be volcanic. Gene suggested that it might be an impact structure like the craters on the moon. In 1960, he led a team to generate a geological map of the moon. Soon he was training astronauts. Here he wears a rocket belt designed to teach astronauts to jump around on the moon. The missions were dangerous. The Apollo 1 team were incinerated in an oxygen fire before launch. The Apollo 11 launch finally put the first 2 men on the moon. Australia's role in this was significant. We had built an early Mills Cross telescope in the 1950s. Our Parkes disk and Tidbinbilla telescopes were vital in controlling the mission and receiving the pictures. In July 1969, I watched with my class at Hunter River High School as Armstrong descended the ladder. Eventually, there were 6 successful landings. The last Apollo mission, number 17, contained a qualified geologist, Harrison Schmitt, trained by Gene. The Oort cloud is believed to exist in deep space between 100 and 100,000 times as far out as the Earth is from the Sun. It contains billions of dirty snowballs. From time to time, some fall into the inner solar system and sweep periodically close to the Sun, causing water to evaporate and bits to fall off, forming long tails that point away from the Sun. Halley's Comet is the most famous. 11 kilometres across, swinging around the Sun every 75 years. The last time was in 1986. When the Earth passes through the tails of comets, we see swarms of shooting stars early in the morning and late at night, radiating from particular points in the sky. In 1993, Carolyn and Jean Shoemaker, as well as David Levy, discovered a new comet called Shoemaker-Levy 9 using a Schmitt telescope at the California Palomar Observatory. The giant planet Jupiter pulled it apart by its own gravity. It collided with the gas giant between July 16 and 22, 1994, in a series of pieces. The largest impact produced a fireball equivalent to a 6 million megaton hydrogen bomb. Although Jupiter vacuums up most of these comets, it was a wake-up call to what could happen to the Earth. The dark areas of the Moon were called Maria, meaning seas, because early astronomers thought that they really were seas. Lunar samples collected revealed that they are olivine basalts that erupted around 3.16 billion years ago and flooded low-lying areas. The lighter-coloured highland areas date up to 4.44 billion years, which is equivalent to the oldest surviving rocks and minerals on Earth, including some in West Australia. So the Moon formed together with the Earth. The Moon is covered in impact craters, the largest of which is the 2,500 kilometre diameter Aitken Basin on the far side of the Moon. So why isn't the Earth still covered in impact craters? Oxygen and water weather and erode rocks. The Earth is geologically active inside. The thinner coloured oceanic rock layers are where new rocks are forming. The older continental bits split apart and move around. Most old impacts have long been destroyed and recycled. The last manned landings in 1972 were followed by a number of deep space probes by various nations to planets, their moons, and even to asteroids and comets. The most famous were the Voyager space probes, first launched in 1977. They found impact craters on moons orbiting the gas giants. Of interest is the asteroid belt, a series of rocky objects that orbit the Sun between Mars and Jupiter. They vary in size between the 950 kilometre diameter asteroid Ceres down to grains of dust. Some of these things can collide and head for the Earth. We try to track them. A Japanese probe has photographed a potentially dangerous near-Earth asteroid that they have named Ryugu. I have met Dr. Andrew Glikson and regard him as one of the most dedicated geoscientists that the nation has produced. After completing 3 science degrees, he joined the West Australian Bureau of Mineral Resources in 1968, searching for minerals and mapping rocks in the hottest and most unforgiving desert areas on the planet. One piece of new technology was the NASA Landsat satellites that photograph the Earth at low altitudes. From 1996, in partnership with Professor Shoemaker, Andrew began investigating impact structures in Australia and around the world. Tragically, Jean was killed in a head-on collision with another vehicle on the Tanami track north of Alice Springs on the 18th of July 1997. His wife survived and continues comet hunting. To honour him, the robot lunar prospector carried his ashes to the moon in 1999. Identifying impact structures requires detective work. Meteors penetrate the crust and explode underground like hydrogen bombs, expending energy upwards and outwards. Shatter cones can be produced. This one is from the giant Archean Sudbury crater in Canada. This is found in dolomite limestone in a Jurassic impact in Tennessee. Tiny quartz sand grains do not cleave as other minerals do, but impact-shocked quartz grains show cleavage planes under a microscope. Old buried craters can reveal themselves following seismic imaging, often for oil. Big ones have a central elastic rebound dome. The dinosaur exterminating Chicxulub crater in Mexico had sinkholes at the margin of the crater. Often meteors are made of siderophile elements close to iron in the periodic table and include nickel and iridium. During the Chicxulub impact, these elements are found at various locations around the world where rocks were forming. We call these KT boundary layers. This one is in Italy. Others include one found at Woodside Creek, Marlborough in New Zealand. Shattered rock at impact sites often contain molten glass. Andrew Glikson spent much time searching for microscopic glass spherules in his desert impacts. These molten glass bits are called tektites. An impact in Asia sent these things into space halfway around the world. They crashed down into soft limestones in the cliffs at Port Campbell in Victoria. My cousins helped find some near my uncle's motel. The growing band of impact researchers look to the moon's craters and believe that we have been hit by large meteors in the past. Most craters have eroded with time. Currently, about 160 structures have been found. I'll present some of these, including crater diameter and age. Bolides are very bright meteors that burn up, explode or impact as they hit the Earth's atmosphere. The first Australians would have learnt to fear the sky when this Boxhall crater formed 30,000 years ago. The good NASA have published these bolide events over a 10-year period. The explosion of a 60 to 190 metre wide meteor over the sparsely populated Tunguska River in Siberia was the largest impact in recorded history, releasing energy equivalent to 10 to 15 megatons of TNT. It killed 80 million trees over a 2,000 square kilometre area. If it had have hit a city, there would have been mega deaths. In 2013, a 20 metre wide asteroid hit the atmosphere at a shallow angle at 19 kilometres per second, and then exploded at a height of 30 kilometres over the town of Chelyabinsk, Russia. The blast had an energy equivalent to 500 kilotons of TNT. The flash was as bright as the sun. Let us watch this film on a young man's mobile. The shockwave damaged 7,200 buildings in 6 cities and injured 1,500 people, mainly from exploding windows. A lot of meteor fragments made it to the ground. These impact problems are insignificant compared to the growing human destruction of life on the planet. Since our hominid ancestors, hundreds of thousands of years ago, discovered tools and fire, humans have been burning stuff. In Australia, it is mostly the bush and various types of solid, liquid and gaseous fuels. The Mauna Loa Atmospheric Observatory sits atop one of the world's highest volcanoes and has been sampling the gases in the air since the 1950s. The greenhouse gas carbon dioxide has increased by 1/3 in my lifetime. A more potent greenhouse gas is methane, which began to increase in 2006. Consequently, global average temperatures are on the rise and accelerating. It is already approaching 1.5 degrees centigrade in 100 years. Projections from these graphs indicate that my grandchildren can expect to see a 5-degree rise within their lifetimes. Ye that have eyes, look at the signs.